There is a theory that says we should never have told the universe we are here. For more than a century, we have been shouting into the dark without even meaning to, a bubble of noise racing outward from Earth at the speed of light. Old radio dramas, breaking news bulletins, radar pulses from Cold War tests, sitcoms and game shows and music broadcasts, all of it spilling into space. We have added deliberate messages on top of that, carefully crafted beacons meant to say hello to minds we have never met. And through all of this, from every direction, the universe has answered with the same thing over and over: silence. Tonight we are going to ask whether that silence is not an accident at all, but a warning about what happens when you make too much noise in a place you do not understand. Think about how different this silence is from the kind you know in everyday life. The silence in your bedroom at night still carries the faint hum of appliances, the distant sound of traffic, maybe a neighbour closing a door, or a dog barking down the street. Even that quiet is full of small hints that other people are nearby. Now imagine leaning back, looking up at the sky, and realising that for all the listening we have done, we have never heard a single unambiguous sign that someone out there is trying to talk. As you listen tonight, keep one question in the back of your mind. Is the universe truly empty, or is something choosing not to speak? Humanity did not begin with a plan to announce itself to the cosmos. We stumbled into it. When the first radio transmitters crackled to life in the early 20th century, nobody was thinking about distant stars. They were thinking about news, music, and the thrill of sending a human voice across a continent. Powerful towers blasted those signals upward as well as outward, their energy spreading in expanding spheres that cared nothing about national borders. When we invented television, we added bright, rapidly changing patterns to that storm of radio waves. Radar came next, sharp bursts designed to bounce off aircraft and asteroids, but just as happy to sail right past them and go wandering between the stars. All of that energy moves at one fixed speed, the speed of light. So right now, a growing shell of our accidental broadcast history surrounds Earth, already large enough to have washed over thousands of other stars. On top of the accidents, we added intention. In the 1970s, astronomers gathered at a giant dish in Puerto Rico called the Arecibo Radio Telescope and did something bold. They pointed the most powerful radio transmitter on Earth at a star cluster 25,000 light-years away and sent a tightly focused burst of information. Inside that signal, they packed a simple counting scheme, a crude picture of a human figure, the sketch of the solar system, and basic facts about our biology and technology. It was our first deliberate attempt to say to the galaxy, this is who we are, this is where we live. Around the same era, engineers and artists worked together on the Pioneer plaques and the Voyager golden records. They attached metal plates and phonograph-style discs to spacecraft that would eventually leave the solar system, engraved with images of human bodies, our position among the stars, and audio recordings of greetings in many languages, along with music from around the world. Each artifact was another message in a bottle, tossed out into a cosmic ocean we barely understood. At the same time, we turned our ears upward. Radio telescopes that could once barely make out the hiss of our own sun became sensitive enough to detect faint emissions from distant galaxies. Astronomers began to point those dishes at nearby stars, to sift through the static for patterns that looked like deliberate broadcasts rather than natural noise. Volunteer projects invited ordinary people to lend their home computers to this search, breaking the data into pieces and checking each piece for the telltale regularity of an engineered signal. As our instruments improved, we picked up the afterglow of the Big Bang, the faint microwave murmur left over from the birth of the universe. We measured flares from pulsars, jets from black holes, and the radio fingerprints of gas clouds forming new stars. We heard the universe breathing and crackling and roaring, but we did not hear voices. This is where an old, deceptively simple question reaches up from history and grabs us by the collar. Physicists have looked at the Milky Way and seen a galaxy with hundreds of billions of stars. Many of those stars have planets. We now have direct evidence of worlds orbiting other suns, some roughly Earth-sized, some receiving similar amounts of starlight. The galaxy itself is older than our planet by billions of years. If life can arise here, the reasoning goes, it should have had plenty of chances to arise elsewhere, and plenty of time to become intelligent, build technology, and figure out how to cross interstellar distances. So why has nobody shown up? Why is there no obvious sign of engineering on a galactic scale? No star-sized structures, no beacons lighting up the sky? This tension between expectation and reality has a name in science circles: the Fermi Paradox. It is the puzzle that sits at the centre of any honest discussion about extraterrestrial intelligence. Over the decades, we have tried to soothe that puzzle with possibilities. Maybe simple life is common, but complex. Tool-using intelligence is rare. Maybe intelligence arises often, but almost always burns itself out in nuclear wars, climate disasters, or runaway technologies before it can spread. This is sometimes called the Great Filter, the idea that there is a bottleneck somewhere in the path from microbes to interstellar travellers that almost nobody makes it through. Maybe advanced civilizations are out there, but choose to observe us from a distance, like zookeepers trying not to disturb their animals. Or perhaps our search methods are simply too crude. We might be listening on the wrong frequencies, at the wrong times, or with the wrong assumptions about what a message would even look like. Each of these ideas carries a different emotional flavour, from grim fatalism to gentle, almost patronising optimism. And yet, if you sit with them long enough, they all share a common trait. They leave us as passive observers of a mystery, staring up at a sky that refuses to explain itself. We keep listening, keep sending, keep turning the knobs on our instruments, while the answer stays out of reach. There is another way to frame the situation that does not treat silence as a puzzle with a missing piece, but as a behaviour. Instead of asking why nobody speaks, it asks what reasons a cautious, long-lived civilization might have to remain quiet on purpose. It encourages us to think less like curious tourists walking into a new landscape, and more like fragile animals waking up in a dark forest where we do not know what else is moving among the trees. As unsettling as that image might be, it is worth holding on to, because it forces us to consider our own actions in a harsher light. Imagine you are standing alone in a dense forest at night. The trees are tall, the undergrowth thick, the moonlight weak enough that everything beyond a few meters melts into shadow. You know that other creatures live here. You hear the snap of a branch, the soft crush of leaves under something that might be walking. You could call out, hoping that whatever hears you is friendly, or at least curious enough not to harm you. You could light a bright torch and wave it around, making your position obvious and letting its glow bounce off eyes in the dark. Or you could freeze and listen, trying to learn as much as you can without revealing where you are. As you picture this, notice what your own instincts tell you to do, even before you start to analyse it. That gut reaction is not about aliens or spaceships, it is about survival. Now turn that feeling back onto our real situation. We have already lit the torch. For more than a century, our planet has been broadcasting a messy, unfiltered record of our existence. Those early radio and television signals are faint by the time they reach other stars, but they are not nothing. On top of that, we have fired radar pulses that could be detectable from far away, and sent narrow, intense messages toward particular targets. We have done this without any clear agreement as a species about whether it is wise. A handful of scientists and artists decided to send those greetings, motivated by hope and curiosity, and a desire to be known. Most humans did not get a vote. Even now, when astronomers propose new, more powerful beacons, there is heated debate inside the scientific community about whether we should be advertising our location at all. As you think about this, try to weigh our excitement about possible contact against the fact that we have no idea who, if anyone, might be listening. The dark forest perspective does not claim to know that hostile civilizations lurk out there, waiting for an excuse to strike. What it does is ask us to take seriously the idea that any species that survives long enough to build star-spanning technology will care very deeply about not being wiped out. If that is true, then the universe we are shouting into may be one where the safest strategy is to stay as quiet as possible, to listen more than you speak, and to treat any sudden, loud newcomer with suspicion. That is a bleak way to think about the cosmos, and it clashes with the warm, hopeful narratives many of us grew up with, where contact with wise elder civilizations brings guidance and unity and wonder. But before we dismiss it, we need to examine the logic behind it carefully. We need to ask what assumptions it makes about life, about resources, and about the limits of trust when distances are measured in light years. Right now, the sky above you looks peaceful. The stars seem small and gentle, pinpricks of light that have been there every night of your life. It is easy to see them as distant decorations, as a backdrop for personal worries and small human dramas. Yet hidden inside that familiar view is a set of questions that cut right down to whether we have made a terrible mistake by calling out. Are we wise explorers, bravely extending a hand into the dark? Or are we noisy children running through a forest where everything else has learned to move in silence? Have we already changed our odds of long-term survival without realizing it? To even begin to answer that, we first have to look at what it takes for any civilization to endure in a universe of limited energy and endless time, and what hard choices emerge when survival becomes the first and most unforgiving rule. To understand why survival rises to the top of every decision in the dark forest picture, we have to step back and look at life in its simplest form. Long before there were telescopes or rockets, there were single cells clinging to vents on the ocean floor, fishing energy out of hot chemical soup. Most of those early experiments failed. A few managed to copy themselves just well enough to stick around. Every living thing that exists today is the result of an unbroken line of survivors stretching back billions of years, a chain where every link avoided complete disaster just long enough to reproduce. That alone tells us something important. Whatever else life might want or value, it cannot want any of it unless it keeps existing. Natural selection is ruthless about this. Organisms that are slightly better at surviving and reproducing tend to leave more copies of themselves. Those copies inherit the traits that help their parents, and over many generations, those traits spread through the population. The process does not care about good or evil, fairness or meaning. It cares only that some configurations of matter keep going and others do not. When a trait helps a lineage stay alive in a given environment, it becomes more common. When it does not, it disappears. So even if individual creatures have all kinds of motives and feelings, from fear and hunger to play and affection, the lineages that last are the ones whose total behaviour patterns add up to staying alive. We can already see this at work in familiar animals. A herd of grazing animals might look peaceful most of the time, but watch what happens when a predator appears at the edge of the field. Heads snap up, bodies tense, and the entire group reorients around the need to avoid becoming a meal. The same animals that were sharing space calmly a moment ago will shove and trample each other at the edge of a cliff if only a narrow path offers escape. It is not that they have suddenly become cruel. It is that in the face of a lethal threat, other priorities are simply pushed aside. Survival is not just on the list of goals. It is the gate that controls whether any goal can be pursued at all. Humans like to imagine ourselves as different because we build cultures and laws and moral systems on top of our biology. We do acts of kindness that seem to go against simple survival instincts. We sacrifice for family, for ideals, for strangers we will never meet. Yet even at the level of societies, there is a quiet selection process. Nations that utterly fail to protect themselves from repeated disasters tend to fragment, to be conquered, or to lose the ability to support their population. Ideologies that demand self-destruction from their followers in every generation do not survive long in the historical record. The world we live in is shaped by the groups that balance their ideals with enough practicality to keep going. That does not mean they were wise or just. It means they avoided collapse better than their competitors. Now stretch this pattern out across the entire history of a galaxy. Imagine countless worlds where life might begin, many of those lives ending in local accidents before they ever spread. A few species climb to intelligence and technology, but only some navigate war, environmental change, and self-inflicted harm well enough to keep advancing. It is those rare survivors, the ones that learn to manage their own power without destroying themselves, that have a chance to become spacefaring civilizations. In other words, the sample of species that reach the point where they must decide whether to respond to a radio signal or build a starship is already heavily biased toward those that treat survival as non-negotiable. Any culture that treats self-preservation casually probably never gets that far. This leads to the first principle in the dark forest way of thinking. Any civilization that is old and advanced enough to detect others and to act across interstellar distances has almost certainly internalized the lesson that extinction is possible and that avoiding it is the foundation for everything else. Even if their minds are nothing like ours, even if their values are utterly alien, they must have strategies that keep them from being wiped out. Otherwise, they would not still be around to hear a signal or see a glowing artificial structure around a distant star. When we imagine such a civilization, we have to assume that somewhere in its planning halls, in whatever form those take, there is a hard rule: do not die out. Survival as a core rule sounds obvious, almost too simple to bother stating, until you combine it with the second reality of the universe. The total amount of matter and usable energy in any region of space is limited. Stars burn their fuel. Planets have only so many minerals, only so much surface area, only so many orbits where life-friendly temperatures are possible. Even if the universe is vast beyond comprehension, any specific civilization will be born in a particular neighborhood that can support only so much growth. At the same time, life has a strong tendency to expand when it can. On Earth, we see bacteria spreading across every suitable surface, plants filling every patch of soil that receives enough sunlight, human populations increasing until they run up against constraints like food, water, or social stability. Expansion is not guaranteed, but it is common. You can see the tension here. A civilization that cares deeply about its survival and has the ability to expand into new territories will feel pressure to do so, because spreading out can reduce its vulnerability. A species that exists only on one planet can be wiped out by a single stellar flare, asteroid impact, or self-inflicted catastrophe. A civilization that exists on many planets and in many independent habitats is harder to destroy in one blow. From a survival point of view, expansion is insurance. At the same time, every step of expansion consumes resources and occupies space that could, in principle, have gone to someone else. Even if no one else is there yet, that space is no longer available to them in the future. We have already lived through slower, smaller versions of this story. Human history is full of migrations into new lands, followed by competition between groups that want the same fertile valleys, trade routes, or mineral-rich mountains. Sometimes this competition takes the form of trade and negotiation. Sometimes it erupts into wars, conquests, and displacements that reshape entire continents. When resources feel plentiful and communication is easy, cooperation looks attractive. When resources feel scarce and trust is low, groups arm themselves and strike before they are struck. The pattern is not absolute. There are exceptions and peaceful periods. But the overall record carries a clear message. When expansion and survival are at stake, suspicion grows quickly, and even well-intentioned neighbours can become threats in the right conditions. Now amplify those conditions to a cosmic scale. Instead of tribes or nations separated by rivers and mountains, imagine civilizations separated by light years. Each one knows that with enough technology, it could in time turn asteroids into habitats, build swarms of solar collectors around stars, or send automated probes that copy themselves using local materials and spread further. These are not wild fantasies. Engineers on Earth have already sketched out how self-replicating machines could, in theory, hop from one star system to another, doubling their numbers with each leap. If even one civilization in the galaxy chooses that path and does not impose strict limits on its growth, it could, over a few million or tens of millions of years, fill huge regions of space with its presence. In cosmic terms, that is the blink of an eye. From the point of view of any other civilization, the possibility of such explosive growth changes the stakes dramatically. It means that a species that looks small and harmless now, broadcasting cheerful television shows and local weather reports, could become a sprawling network of colonies and machines later. You do not know their long-term values. You do not know how stable their politics are, or what happens when they discover new energy sources or weapons. All you know is that they exist, that they are capable of rapid change, and that if they expand without restraint, they could eventually control resources you might need to ensure your own survival. The uncertainty is not just about what they are like today, it is about what they might become after a few more technological revolutions. This is where survival, expansion, and limited resources begin to interact in a disturbing way. Imagine you are part of a council on a far-off world, one that has managed to endure for millions of years. Your people have seen comets diverted, stars studied in detail, perhaps even neighbouring systems gently harvested without exhausting them. You have avoided self-destruction through careful planning and hard cultural lessons. One day, your sensors pick up a faint, repeating signal from a distant star. After long study, you realise it is artificial, produced by a young technological civilization that has just learned to use radio waves. They are far behind you, but if their history is anything like yours, they may catch up much faster than you are comfortable with. How do you respond? If you decide to do nothing, you accept that a new, unpredictable actor will continue to grow and develop. They may remain peaceful, never leaving their home system, or they may eventually develop the ability to reach you. If you attempt to talk, you must send a signal that reveals your awareness and possibly your location. You must trust that they will interpret your message in the way you intend, not as a threat or a map leading back to your own worlds. You must also trust that no third party, listening in on your exchange, will use it as a clue to find and target you. If, on the other hand, you decide to eliminate the risk early, you face the moral weight of destroying an entire emerging civilization before it has a chance to show its nature. That action might go against every ethical story you tell about yourself, but from a cold risk management perspective, it would remove a source of uncertainty. Notice that in this situation, the danger comes not only from malicious intent, but from lack of information. You do not know their motive. You cannot reliably learn them, because any communication is slow, filtered through different languages and cultures, and always arrives years or centuries after you send your own words. Even if you get answers that sound friendly, you can never be sure they are sincere, or that their future leaders will interpret your relationship in the same way. You are also aware that they may be running exactly the same calculations about you. They do not know if you are peaceful or predatory. They do not know how powerful you truly are. In the absence of shared rules or a higher authority to mediate, every side is left alone with its fears and its survival instinct. You can probably feel how quickly this spirals into a pattern that is hard to break. Each side, acting out of caution rather than hatred, may become more dangerous simply because it imagines what the other could do. The more each one values its own survival, the more it is tempted to remove uncertainties before they grow. That does not mean every civilization will choose aggression. Some may decide that the moral cost of a preemptive strike is too high, or that the risk of exposing themselves by attacking is worse than the risk of waiting. But when you consider many civilizations over long spans of time, even a small fraction choosing the harsh option could fill the galaxy with invisible scars, dead worlds that never got the chance to answer back. So far, we have been looking at this logic from the outside, as if we were watching a game played by unknown actors. The uncomfortable part comes when we realize that we are not spectators, we are pieces on the board. Our early broadcasts have already announced that there is at least one world here with technology, curiosity, and a tendency to shout without thinking about who might be listening. If the dark forest picture captures even part of the way long-lived civilizations think, then our noise is not just an odd quirk, it is a move in a game we barely understand. To grasp how that game might unfold, we have to go deeper into the problem of communication itself, and see why, across the vastness of interstellar space, even honest attempts to talk can feed suspicion instead of dissolving it. When you and I talk, a lot of things happen automatically that we barely notice. We share a language. We share similar bodies and senses. We live in the same gravitational field and breathe the same air. We can see each other's faces, hear tone of voice, and instantly ask for clarification when something sounds confusing. Even with all of that, humans still misunderstand one another constantly. Friendships break over misread text messages. Nations go to war over words that were interpreted through layers of fear and pride. Now imagine trying to have a careful, nuanced conversation with a mind you have never met, living in an environment you have never seen, using symbols and concepts that evolved on an entirely different world, with years or centuries of delay between every exchange. For a long time, we pictured interstellar communication as a kind of cosmic ham radio hobby. Two curious civilizations point their dishes at the sky, beam out a friendly hello, and then begin slowly trading math puzzles and encyclopedia pages, like pen pals separated by distance rather than oceans. It is a gentle image, one where the main challenge is technical. Can we encode enough information in a signal that has to travel for light years through noisy space? Can we build receivers sensitive enough to catch faint whispers from distant suns? In that vision, once we crack the engineering problems, everything else feels like an inevitable slide toward mutual understanding. The dark forest perspective asks us to reconsider that assumption. It says that even if the engineering works perfectly, the deeper barriers to trust remain. Let us walk through a simple thought experiment together. Imagine two civilizations, far apart in the galaxy, who both detect each other's radio noise. Each one knows only a few basic facts. The other exists. The other has technology at least advanced enough to generate artificial signals. The other lives on a world that orbits a star, which might have other useful resources in its system. Beyond that, everything is guesswork. The first temptation is to say that math and physics will save us. After all, the laws of nature are the same everywhere, as far as we can tell. Perhaps our messages could begin with prime numbers, wave frequencies, or diagrams of atoms, building a shared vocabulary step by step. In principle, that is possible. In practice, even if both sides manage to decode a basic scientific language, they still have to leap from there to questions of intention and future behavior. Knowing that someone understands hydrogen and gravity does not tell you what they will do with that knowledge once they can build fusion reactors or weapons. There is also the problem of delay. Suppose you send a message to a star 20 light years away. It will take 20 years to arrive. If the recipients answer immediately, their reply will take another 20 years to get back to you. That means 40 years between each full turn of the conversation. In those 40 years, your civilization may change dramatically. Governments fall, technologies leap forward, cultures rewrite their values. The same is true on their side. By the time you receive their friendly introduction, the people who wrote it may be gone, replaced by leaders with very different ideas. When you try to judge their character from what you receive, you are always looking at a ghost, a snapshot of who they were decades ago, not who they are now. Even here on Earth, we know how risky it can be to rely on old information about a rival. Nations that were weak 20 years ago may now have strong economies and modern armies. Groups that seemed stable may have fractured into factions. If you act based on outdated assumptions, you can stumble into disaster. Now project that difficulty onto a timeline where every single message is a historical artifact by the time it arrives. You and the other civilization are trying to decide whether to trust one another while staring through a narrow keyhole at each other's distant past. Out of this mismatch between what you need to know and what you can know grows something that dark forest thinkers call the chain of suspicion. It begins with simple questions. Are they peaceful? Do they value cooperation? Will they respect our autonomy? Very quickly, though, the questions compound. Even if they are peaceful now, will they stay that way as they expand and compete over resources? Even if their current leaders are sincere, can future leaders bind themselves to those promises? Even if they are completely honest with us, can we be sure that we are correctly interpreting subtle cues in their messages, rather than projecting our own hopes or fears onto them? It gets worse. You also have to wonder what they think of you. They may be asking the same questions in reverse. Are you peaceful? Will you stay that way? Can your future rulers be trusted? If they believe that you might someday become a threat, they might feel pressure to act first for their own safety. So you find yourself in a loop. You suspect that they suspect that you might someday attack them. They suspect that you suspect they might think about attacking first. Each step adds another layer of anxiety, and each layer nudges both sides toward preparing for the worst. On Earth, we have seen versions of this dynamic play out many times. During tense periods between nuclear-armed nations, each side knows that the other does not want to start a catastrophic war. They also know that a surprise first strike could offer a temporary advantage, and that misinterpreting a radar blip or a satellite glitch as an attack could trigger disaster. The result is a constant effort to read intentions through incomplete data, backed up by hair-trigger responses in case those readings are wrong. Even without anyone wanting a war, the structure of the situation keeps both sides nervous and heavily armed. Add a few miscommunications or false alarms, and conflict can erupt almost by accident. Now remove the possibility of quick, clarifying phone calls, emergency hotlines, or real-time negotiations. Replace them with single-line messages that travel for years. You can begin to feel the gravity of the problem. Any signal you send is both an attempt at communication and a declaration that you exist and are active. Any response you receive is both a potential bridge and a data point revealing how fast the other side decodes complex information, how quickly they build new devices, how their thinking evolves. In a universe where survival is prized and expansion is possible, those data points can look less like charming cultural exchanges and more like early reconnaissance in a long-term strategic contest. At this point, someone usually says that advanced civilizations would be wiser than we are, less trapped by fear. They might have left behind the primitive instincts that drive us into arms races. That is a hopeful thought. It may even be true in some cases. The difficulty is that we cannot rely on it, because there is no mechanism that guarantees wisdom emerges faster than power. On our own planet, we have watched technologies outpace our social systems again and again. We created tools that let us alter the climate before we built reliable global agreements to manage them. We learned to split atoms and build thermonuclear weapons within a single human lifetime, long before we developed robust safeguards to ensure they would never be used. Technological progress often follows a steep curve. For long stretches, change is slow and incremental. Then, triggered by a few key insights, it accelerates. In the last few hundred years, humans went from horse-drawn carts to spacecraft and global communication networks. The pace of innovation in computing, genetics, and materials science suggests that we are still near the bottom of that curve. For an outsider watching from afar, our trajectory would be hard to predict. A civilization that checks in on us every few decades through our broadcasts would see an explosion of capabilities with each snapshot, with no guarantee about how we will wield them. The same can be said in reverse. If we were to detect a younger civilization just starting to use radio, we would face a similar puzzle. We would see their current level of technology, but not their future choices. Because we know from our own history how quickly things can change, we would have to build projections. How quickly might they master fusion? How soon might they develop self-replicating probes? What political structures are they building, and how stable are those structures likely to be when stressed by rapid change? Each projection would carry uncertainty. The more uncertain we are, the more our survival instinct whispers that we should not wait quietly for a worst-case scenario to become reality. Put this together, and you get a grim but coherent pattern. Survival is paramount. Resources and space are limited. Technological growth can be explosive. Communication is slow and easily misread. Each new contact is therefore a potential risk, not just a potential friendship. When a civilization becomes aware of another, it must decide how to act under deep uncertainty. Does it reach out and hope that goodwill is enough? Does it watch quietly, gathering more information while staying hidden? Or does it decide that the safest option is to remove the risk before it grows teeth? It is important to notice that in the dark forest framing, the push toward hostility does not require evil intentions. Even if every civilization in the galaxy began with a desire to coexist, the structure of the situation still loads the dice. Imagine a forest where every animal is gentle by nature, but knows that some rare mutation could turn a neighbor into a predator in the next generation. That knowledge alone might be enough to make even gentle creatures wary of newcomers. Over long spans of time, the rare few that acted preemptively might be the ones that survived and spread, while the trusting ones disappeared without leaving a trace. That kind of invisible selection would tilt the population toward caution, even if no individual ever woke up wanting to be cruel. You might be wondering at this point whether there is any path out of this spiral. Could advanced minds create shared rules, cosmic treaties, or signaling conventions that guarantee safety? People have proposed ideas like that. Perhaps there is a widely known pattern of harmless messages that everyone recognizes as a promise of peace. Perhaps there are subtle ways to announce your presence while hiding your exact location. Perhaps there is an unspoken code among the elders of the galaxy to leave younger species alone until they reach a certain level of maturity. These possibilities are not impossible. The problem is that we have no way to verify them from where we sit. If such norms exist, we have not yet seen clear evidence of them. From our current vantage point, all we see is a quiet sky and our own habit of sending noisy, careless signals. We do not know whether somewhere in that silence, ancient civilizations are holding their breath, listening intently, tracking every new radio bubble with growing unease. We do not know whether any of them have already decided on hard rules about what to do when a new world lights up. For all our telescopes and equations, we are still in the position of someone walking through a dark forest without knowing its predators, its safe zones, or its customs. We can theorize, but the cost of guessing wrong could be everything. So far, we have focused on how mistrust can arise even when both sides want to avoid harm. There is another layer still to add, one that makes the dark forest picture even more chilling. It is the realization that once you combine all these pressures, the option that looks most reasonable on paper may also be the most terrifying in practice. A decision tree that begins with innocent questions about survival and uncertainty can end with a conclusion that feels like a moral disaster. To see how that happens, we have to trace the logic all the way to its endpoint, where a cold but consistent strategy emerges from the shadows. Once you accept the basic pressures that shape cosmic civilizations, the decision tree almost builds itself. You have a survival drive that sits above every other priority. You live in a universe where resources are finite, where expansion is tempting, and where technology can leap forward in a few short centuries. You know that communication is painfully slow and always filtered through guesswork, and you have just discovered that you are not alone. Standing at that crossroads, you really only have three broad options. You can reach out and announce yourself as a friend. You can stay hidden and watch, hoping to gather more information without being noticed. Or you can act early to eliminate the source of uncertainty before it grows strong enough to threaten you. Each option carries its own risks and its own moral weight, and none of them come with guarantees. The unsettling part is that when you analyse them through the lens of survival, the one that looks safest on paper is also the one that feels least acceptable in our hearts. Start with the friendliest choice. You decide to send a message. You announce that you see the other civilization, that you wish to communicate, perhaps even to share knowledge and cooperate. To do that, you must reveal something about your location and your level of technology. You might try to be clever, bouncing your signal off distant objects, or using subtle encodings. But any sufficiently advanced listener will be able to backtrack the path of your signal and at least narrow down where you are. In effect, you are lighting a small lantern in the forest and calling out that you are nearby. In the best case, your counterpart responds with equal openness. You begin a long, slow conversation, building trust over centuries. Perhaps you exchange scientific insights, art, and philosophies. Perhaps you eventually coordinate on shared projects, like mapping the galaxy or avoiding dangerous astrophysical events. That is the optimistic vision that has fueled many dreams of contact. It is not impossible. The trouble comes when you remember the chain of suspicion. You cannot be sure that their friendly tone is sincere. They cannot be sure of yours. Both of you know that messages are old by the time they arrive, so you must always wonder who is truly behind them. Even if every exchange is honest, your broadcasts tell them how fast you are progressing. They can measure the sophistication of your signals, your energy usage, and the structure of your transmissions. From this, they can infer your scientific understanding and your industrial capacity. With each new message, you give them a clearer picture of your trajectory. That information could be used to reassure them that you are stable and peaceful. It could also be used to fine-tune a future attack. You are teaching a potentially dangerous neighbour exactly how to hurt you if they ever decide to try. The second option seems safer. You stay quiet, you listen, you collect data without revealing that you are there. If the other civilization is young and noisy, you might be able to map their continents, watch their atmospheric chemistry, and eavesdrop on their broadcasts, the way we already study exoplanets and distant galaxies. You can build models of their society and try to predict whether they are likely to become a threat. You avoid the immediate risk of exposure that comes with saying hello. At first glance, this feels like the cautious choice. You are not taking aggressive action, you are simply gathering information. But the deeper you look, the more cracks appear. Remaining silent does nothing to affect their growth. They continue developing technologies, exploring their surroundings, and perhaps sending their own probes outward. The longer you wait, the more capable they become. If at any point your models suggest that they might be dangerous, you will have to face the same awful question you are dodging now, except you will be facing it later, against a stronger opponent. There is also the possibility that they will detect you first. Your quiet listening posts might still leak some signature. Your own history might have left faint traces in the environment, or they might simply be lucky, catching a reflection of one of your ships, or picking up a transient signal you thought was safe. In that moment, your restraint buys you nothing. They now know that you exist, and the chain of suspicion begins from their side instead of yours. You have lost the initiative, and perhaps ceded the safer vantage point. This brings us to the third option, the one the dark forest theory is named for. You act fast and from a distance. As soon as you are reasonably sure that the signal comes from a technological civilization, you direct a weapon at their star system and attempt to erase them before they advance any further. You never announce yourself. You never send a greeting. You simply wait for the physics to play out. Years or centuries later, their world is sterilized by an impact or a beam they never saw coming, and the forest returns to silence. From our human point of view, this is horrifying. It is the annihilation of an entire emerging culture, perhaps one filled with art and love and curiosity, snuffed out before it can bloom. It offends every moral story we tell about the value of life and the importance of giving others a chance. If we only listen to our empathy, this option feels unthinkable. Yet if we listen coldly to the survival logic, it has frightening advantages. It removes a source of long-term risk. It avoids the dangers of revealing your own location through conversation. It requires only that you detect them early enough, and that your technology is ahead of theirs by a margin large enough to make retaliation unlikely. Importantly, the dark forest argument does not claim that civilizations enjoy doing this. It does not picture a cosmos filled with sadistic predators. Instead, it suggests that any civilization which allows its survival calculus to dominate every other consideration will at least be tempted by this path. Over cosmic timescales, those that choose it may be overrepresented among the survivors, not because they are noble, but because their strategy leaves fewer openings for others to destroy them. In a harsh evolutionary environment, even reluctant hunters can outcompete trusting wanderers who walk unarmed and unguarded. You might object that advanced beings could build a different framework, one that puts ethics above raw survival. Perhaps they decide that it is better to risk extinction than to commit what amounts to preemptive genocide. That is a real possibility. We can imagine cultures that build their entire identity around restraint and compassion, that engineer their own instincts to suppress fear-based aggression. The problem is not that such cultures cannot exist. The problem is that in a universe governed by selection, we cannot assume they will dominate. A single civilization that does not share those scruples and that adopts preemptive elimination as a strategy could, over time, prune away many of the gentler ones. This pruning does not have to be complete to change the character of the galaxy. Imagine that in the early history of the Milky Way, dozens or hundreds of technological civilizations arose. Some chose to stay quiet, some chose to talk, some chose to strike preemptively when they detected others. After billions of years of this, what would remain? Perhaps a few extremely cautious, extremely hidden survivors, and a wide scattering of worlds where promising species once looked up at the sky and wondered if they were alone, just as we do, only to be erased before they ever launched their first interstellar probe. From the standpoint of any young species like ours, the result would look the same. A sky full of stars and no obvious neighbours. Here is where the silence starts to feel less like an absence and more like a possible signature. If even a small fraction of advanced civilizations adopt a shoot-first strategy, and if those civilizations have had millions or billions of years longer than us to act, the cosmos we see could already be shaped by their decisions. We would not see the ones who were destroyed. We would only see the quiet survivors who either hid well enough or were lucky enough not to be noticed. The lack of loud, obvious galactic empires could be the negative space left by past purges. It is a chilling thought, because it flips our interpretation of the data. Instead of saying nobody is out there, It whispers that someone might be, and that they have strong opinions about how loudly others should speak. Of course, this is still speculation. We do not have direct evidence that anyone has ever carried out such a preemptive strike. We do not know whether civilizations capable of interstellar travel would truly behave this way. There are many other explanations for the Great Silence, from rare life to self-destruction to non-interference policies. The dark forest theory is not a proven fact. It is a model, a way of reasoning under ignorance. Its power comes from how neatly its pieces fit together, and from how closely its logic mirrors patterns we already know from ecology, evolution, and human history. There is a secondary discomfort tucked inside this model. It suggests that you do not need very many aggressive actors to create a dangerous environment. Even if most civilizations are peaceful, the presence of a few that are willing to fire from the shadows can push everyone else toward caution. If you suspect that somewhere out there exists at least one culture that will attack if it learns your location, the safest move is to minimize the chances that anyone at all can pinpoint you. That leads to radio silence, to carefully masked energy use, to structures designed to look as natural as possible from a distance. Over time, that can produce a galaxy where everyone is hiding from everyone else, just in case. As you turn this over in your mind, notice what it does to our own posture. We grew up in a cultural landscape full of hopeful stories about contacting wise beings among the stars. We sent our early messages under the influence of those stories, imagining that the main risk was being ignored. The dark forest view asks us to revisit those choices from a different angle. It asks whether, if this logic is even partly right, turning up the volume on our cosmic broadcast might be like shouting in a hunting ground where we do not know the rules. It does not say that disaster is certain. It says that we have never really calculated the odds. There is an even sharper twist. In the classic picture of the Fermi puzzle, we wonder why nobody else has called us. In the dark forest picture, the more urgent question becomes whether anyone has already noticed that we exist. Our radio bubble has been expanding for more than 100 years. Our radar pulses have stabbed into the sky many times. Our bright artificial emissions make Earth look different from any dead rock at the same distance. If there are watchful eyes out there, they may already have logged our presence, filed us in some risk category, and perhaps even debated what, if anything, to do about us. We do not know if that has happened. We may never know, unless someone chooses to act in a way we can detect. But in this framework, our position is uncomfortably clear. We are no longer hypothetical players in a thought experiment. We are a young, noisy civilization in a forest that might contain very old and very cautious minds. The question is not just how they might think about us. It is also how we should think about ourselves. How visible are we already, really? How bright is our lantern compared with the background of the sky? And what does a serious audit of our own noise say about the path we have already chosen, perhaps without meaning to? If all of this makes you feel like a character who has wandered into the forest with a lantern, the next natural question is simple and uncomfortable. Just how bright is our light really? Are we a faint flicker lost in cosmic noise, or a glaring beacon that any watchful eye could spot? To answer that honestly, we have to audit our own presence in the sky, not the one we see when we look up, but the one we create when others look back at us. The easiest place to start is with our radio bubble, because that is the part of our footprint we talk about most. For a little more than one human lifetime, Earth has been leaking radio and television signals into space. Early broadcast towers sent out powerful analog transmissions in all directions, bright and messy compared with the narrower, more efficient signals we use today. Military and planetary radar systems added sharp pulses that blasted into the sky with enough power that, in theory, a civilization with gigantic receivers could notice them from dozens or hundreds of light years away. All of this energy travels at the speed of light, forming an expanding shell around our planet. Picture that shell for a moment. At its leading edge is the very oldest content we ever sent, the crackling experiments of early radio pioneers, the first regular news bulletins, the grainy black and white images of variety shows and game broadcasts. Closer in, the shell thickens with mid-century dramas, Cold War tests, and the first colour signals. Near the inner layers are the more compressed, targeted transmissions of the late 20th and early 21st centuries, along with satellite links and digital data. The whole structure is a layered history of our technological adolescence, a moving archive of everything from trivial entertainment to the announcements of wars and scientific breakthroughs. In terms of the galaxy, this bubble is tiny. The Milky Way is roughly 100,000 light-years across. Our radio noise has travelled out a bit more than 100 light-years. That means it has reached only a small fraction of the stars in our home galaxy, a thin local neighbourhood around the Sun. But small does not mean empty. Astronomers have catalogued many stars within that radius, some similar to our Sun, some with planets already detected. For any civilization that happens to live on a world in that zone with instruments slightly more capable than our own, Earth would not be a silent rock. It would be a source of structured, unnatural radio patterns that began abruptly about a century ago and have continued ever since. There is an important nuance here. Detecting those signals is not easy. The farther they travel, the weaker they become, spreading out and blending with natural cosmic noise. Some researchers argue that our unintentional broadcasts are already too faint to notice beyond a few light years, unless you build receivers far larger than anything we have. Others counter that a civilization with a significant head start on us might have devoted serious resources to all sky monitoring, making our leakage clear against the background. The details depend on assumptions about their technology and priorities. What matters for our story is that our presence is not zero. It is at least conceivable that someone with enough patience and hardware has already seen the flicker of our lantern. On top of this unplanned glow, we have deliberately thrown a few sharper beams into the dark. The Arecibo message, sent in the 1970s, was a tightly focused blast of radio waves aimed at a distant star cluster. Encoded in that blast was a pattern chosen so that a mathematically literate mind could reconstruct simple images and concepts, including our numbers, basic chemistry, and a crude human figure. It was never meant as a practical conversation starter. The target is so far away that any reply would take tens of thousands of years to reach us. It was more of a statement that we could do it, an experiment in how to format a greeting to the cosmos. But it is still a louder, more intentional mark than our general leakage. Then there are the objects we have physically launched out of the solar system. The Pioneer probes carry small metal plaques for anyone who might someday intercept them. The Voyager spacecraft carry golden records that store encoded sounds and images from Earth. These artifacts drift silently through interstellar space, not broadcasting anything on their own, but detectable if they happen to pass near a sensor or become part of a salvage effort by a species that sweeps up debris. They are unlikely to be found given the vast emptiness between stars. Still, from our perspective, they represent another way in which we have already committed to being knowable. They are invitations written in metal, tossed into a current we cannot steer. More recently, some scientists and enthusiasts have proposed a new phase of deliberate signalling. Instead of waiting for chance intercepts of our old broadcasts, or relying on low-odds encounters with probes, they suggest we build powerful, sustained beacons. These would target nearby stars with known planets, broadcasting carefully chosen messages that say not only that we are here, but also that we are ready to talk. The field even has a name: messaging to extraterrestrial intelligence. It is the more outgoing sibling of the older practice of simply searching and listening. As you might expect, not everyone likes the idea. The argument in favour of active messaging rests on a few key claims. One is that any civilization able to threaten us over interstellar distances would already know our planet is interesting. They could detect our oxygen-rich atmosphere, the chemical signatures of life, and perhaps even the artificial glow of city lights on the night side. From that perspective, trying to hide now is like whispering after years of shouting. Another claim is that the potential benefits of contact are immense. An older civilization might help us navigate existential risks, share insights about physics, or simply confirm that intelligence is not a lonely accident. Proponents see silence not as safety, but as a missed opportunity. On the other side of the debate are those who look at the same facts and reach almost opposite conclusions. They point out that we have never done a proper risk analysis of active broadcasting. We have no data on the distribution of motives among advanced civilizations. We do not know whether announcing ourselves increases or decreases danger. They argue that decisions that could affect the survival of the entire species should not be made by small groups of scientists or organizations without a broader global consensus. They also question the assumption that any technologically advanced civilization would automatically be benevolent or interested in mentoring us. History, even just our own, offers many counterexamples. There is also a more subtle worry. By crafting bright, information-rich beacons and pointing them towards specific stars, we would be creating something more like a clear target than a vague glow. Our current leakage is messy and diffuse. A dedicated beacon is a precise, high-power arrow that says we are here, we know you might be there, and we are willing to connect. In a universe where we are confident that no one means us harm, that would be an act of courage and curiosity. In a universe where we admit we do not know the intentions of others, it could also be seen as a gamble taken on behalf of billions who never got to weigh in. Complicating all of this is the fact that our visibility is not limited to radio. Even if we turned off every transmitter tomorrow, Earth would still look strange from afar. Our atmosphere carries elevated levels of gases produced by industry, agriculture, and fossil fuel burning. Our night side glows with artificial light, a spiderweb of illumination tracing our cities and roads. Large telescopes placed around nearby stars might see our planet transit across the face of the sun and analyze its thin envelope of air. To any civilization that had bothered to build such instruments, Earth would stand out as an inhabited world that recently entered a phase of rapid industrial change. This means that hiding completely may not be an option. We can reduce our radio noise. We can decide not to build new beacons, but the basic biological and technological fingerprints of our existence will still sit on top of this world for a long time. In some sense, we crossed the threshold of anonymity the moment we began altering our planet on a global scale. The question is no longer whether we are visible, but how much extra attention we want to draw beyond what our mere existence already demands. It is the difference between being noticed as a lit window in the distance and walking out onto the balcony to wave a bright flag. From here, it is useful to imagine a few broad scenarios that could be playing out without our knowledge. In one, our signals have reached worlds where no one is listening, or where life never made it past simple forms. The bubble of our noise washes over empty ecosystems and desolate rocks, leaving no impression. In another scenario, our broadcasts have brushed past civilizations that are so advanced that we barely register. To them, our chatter might be like faint radio static, instantly recognized, catalogued, and dismissed as uninteresting. They might consider us too primitive to engage with, in the way we might ignore the daily movements of bacteria in a petri dish. There is a different possibility that fits more closely with the dark forest idea. Somewhere within the radius of our radio shell, a cautious civilization might have receivers trained on the sky, always alert for signs of new technology. When our first broadcasts reached them, they marked the time and location. They may now be watching us evolve through our own emissions, observing our conflicts and scientific leaps the way we watch historical footage. In that case, our planet sits in their archives as a developing case file, its label updated every few decades as more data arrives. Whether that file is tagged as a potential partner, a curiosity, or a future risk is something we cannot know. In the most unsettling variation, the Watchers have already moved beyond observation. Perhaps they decided long ago that any new technological species in their vicinity should be guided, contained, or removed before it becomes unpredictable. Their tools might not be dramatic death beams fired from across the galaxy. A more plausible strategy could involve slower, more flexible probes, machines that can lurk on the edges of a system, gather detailed information, and act only if certain thresholds are crossed. From our point of view, such probes would be almost impossible to detect with present-day instruments, especially if they blended in with natural objects. These scenarios are not presented as certainties. They are thought experiments that highlight how many different stories could be compatible with the same silent sky. Right now, we have no way to distinguish between a universe where nobody has noticed us and one where our existence is already logged in a dozen alien archives. We do not know whether our accidental beacon has changed the behavior of anyone else, or whether it is simply another faint whisper lost in the star-filled background. What we do control, at least in principle, is what we choose to do next with that beacon. Do we amplify it, shape it, and aim it on purpose? Or do we start treating it as a potential liability? As you let these possibilities settle, it is worth noticing how much of our anxiety comes from the unknowns. We do not know how common life is. We do not know how often intelligence evolves. We do not know whether technological civilizations tend to self-destruct, to retreat inward, or to spread aggressively. We do not know if there are unwritten rules already in place among older species. In such a thick fog of ignorance, any theory that offers a clear rule, like stay quiet in the dark forest, can feel compelling simply because it is decisive. But decisiveness is not the same as truth. A vivid story can be wrong. This is where our investigation has to broaden. So far we have treated the dark forest logic as if it might be the hidden engine behind the silence. Yet it is only one of many frameworks that scientists and thinkers have proposed. Some argue that the bottleneck is not in communication or survival strategies, but in the basic emergence of complex life. Others suggest that intelligence may be more like a brief flare than a stable state, something that arises and then burns out in relatively short bursts. There are ideas that advanced civilizations choose a path of extreme non-interference, quietly watching younger species without ever revealing themselves. There are even arguments that we are simply too early, that the galaxy will be full of chatter in the far future, but not yet. Each of these alternative pictures reshapes the meaning of our own beacon in a different way. In a rare life universe, our signals are more precious than dangerous. In a self-destructive universe, they may be a warning sign of a phase that rarely ends well. In a non-interference universe, they might be the trigger that starts some long-planned test of whether we are ready for contact. To weigh these ideas honestly, we have to set aside for a moment the haunting image of a hunter-filled forest and ask a more basic question. What other stories could explain a sky this quiet? And what do they say about who we are and what might come next? When you look up at the night sky and hear nothing, it is tempting to grab onto the first explanation that feels solid. The dark forest picture is one such explanation, but it is not the only one. Scientists and storytellers have built a whole shelf of ideas to account for the great silence. Each one rearranges the same basic facts into a different pattern. As we walk through them, notice not only what they say about the universe, but also what they reveal about our own hopes and fears. One of the most influential ideas is often called the rare Earth picture. In this story, the universe may be full of planets and simple life, but the exact combination of conditions that produce complex, technological civilizations is extremely uncommon. Earth is not just one cradle of life among many. It is an unusually lucky roll of the cosmic dice. Our stable star, our protective magnetic field, our plate tectonics, our large moon, our long periods without total sterilizing events, all of these become part of a delicate recipe that almost never comes together. Under this view, the silence is not threatening. It is just what you would expect if almost nobody else made it this far. When we point radio dishes at the sky and hear only natural noise, that is because there simply are not many other broadcasters. If a few exist, they might be so far away that their signals have not reached us yet, or are too faint to detect with our current instruments. The universe is not a hunting ground in this story. It is a vast, mostly empty wilderness, where we are one of the very few fires that ever caught and stayed lit. There is something flattering and comforting about this. If we are rare, then we are precious. Our existence becomes a kind of cosmic privilege, and with it comes an implied responsibility. We are not in danger because someone is hiding. We are in danger because there may be no one else to carry the torch if we let it go out. The rare Earth frame turns the silence into a call for stewardship. Protect this planet. Protect this fragile technological bubble. If we vanish, a whole region of the galaxy might go dark forever. But rare does not mean unique, and rarity is hard to measure from a sample size of 1. In recent decades, astronomers have discovered thousands of planets around other stars. Many are nothing like Earth, but some are surprisingly similar in size and temperature. We are just beginning to learn how many worlds might have liquid water, stable climates, and long lifetimes. The data are not yet strong enough to say whether Earth is an exception or an expected type. The rare Earth idea remains plausible, but not yet proven. It may turn out that complex life is difficult, but not astronomically unlikely, which pushes us back toward wondering why we do not see more technological echoes. That brings us to another powerful concept, the Great Filter. Instead of focusing on how hard it is to get started, this picture imagines a series of steps from lifeless rock to interstellar civilization. At each step, there is a chance of failure. Life has to arise from chemistry, single cells have to evolve complexity, multicellular organisms have to appear, intelligence has to emerge. That intelligence has to invent technology. That technology-rich society has to avoid destroying itself. Somewhere in that chain, the Great Filter says, there is at least one step that almost nobody passes. The unsettling part is that we do not know where the filter sits. If it is behind us, meaning that the hard steps were in our deep past, then our current existence is already a miracle of survival. Perhaps the leap from non-living chemistry to self-replicating cells is almost impossible, and we won that lottery long ago. In that case, the silence is simply the sound of all the planets where life never quite managed to ignite. The future, though still dangerous, is not cursed by an invisible wall of probability. We have already slipped through the narrowest gate. If the filter lies ahead, the picture darkens. That would mean that many worlds may reach our present level, with industry, global communication and spaceflight, but almost all of them fail to push beyond this phase. They choke their atmosphere, exhaust their resources, misuse powerful technologies, or fall into conflicts they cannot escape. From this angle, the quiet sky becomes a graveyard of civilizations that burned brightly for a moment and then vanished, leaving only faint geological scars. Our current moment then feels less like a triumph and more like a dangerous ridge, with a steep drop hidden in the fog just a little further along. Emotionally, these two placements of the filter pull in opposite directions. A filter in the past encourages gratitude and a cautious optimism about the future. A filter in the future turns our era into a warning. It suggests that the problems we worry about, like climate instability, engineered pathogens, artificial intelligence misalignment, or uncontrolled weapons, might not be random. They might be the standard obstacles that almost everyone fails to solve. In that view, our choices in the next few centuries are not just local politics. They are a test that almost no one has passed. Notice how this connects to the dark forest idea without being identical to it. The Great Filter is mostly about internal hazards, the ways a civilization can destroy itself. The dark forest is about external strategy, the ways civilizations might destroy others. Both are trying to answer the same observational fact, the lack of clear, loud, technological signatures in the sky. It is possible that both are at least partly right. Many cultures may fall to their own mistakes, and a few survivors may adopt extreme caution toward any newcomers they detect. Another answer to the silence leans in a very different direction, one that feels strangely gentle and unsettling at the same time. This is sometimes called the zoo picture. In this story, the galaxy does have older, more advanced civilizations, but they have collectively decided not to interfere openly with younger species like us. They might watch us, perhaps even study us, but they avoid doing anything that would disrupt our natural development. To us, the sky remains quiet not because nobody is there, but because everyone who might talk has agreed that the kindest thing they can do is remain invisible. There are various motives people imagine for such restraint. Perhaps they follow a strict ethical rule that says contact should only happen after a civilization crosses certain thresholds, like abolishing war or learning to manage its planetary environment wisely. Perhaps they are running a long-term experiment, curious to see how minds like ours evolve when left alone. Perhaps they remember the damage caused by past interventions and have sworn not to repeat those mistakes. In any case, the silence becomes a choice, a patient waiting rather than a threatening absence. The zoo frame is appealing for obvious reasons. It preserves our hope that cosmic elders exist and that they are wise rather than predatory. It allows us to imagine mentors who could step in if we are about to make an irreversible mistake. It also offers a comforting explanation for why we do not see sprawling alien engineering projects. If they can hide from us, they can hide their energy use, their structures, and their traffic between stars. We are like animals in a nature reserve, dimly aware of a fence but not of the carefully hidden observation posts beyond it. The problem with this picture is evidence. We have seen no unambiguous sign of deliberate concealment. No clearly artificial anomalies that demand the presence of a coordinating network of guardians. The few strange things we do encounter in our observations, like unusual stellar dimming or odd radio blips, have so far either faded or found mundane explanations. It is always possible that we are missing key clues or looking in the wrong way. Still, from a scientific standpoint, the zoo idea remains speculative. It tells a story we like, but so far it rests more on what we imagine than on what we measure. There are other, more mundane explanations that do not rely on rare miracles, harsh filters, or secret councils of elders. One is simply that we have barely begun to look. For a long time, our searches for artificial signals have scanned only narrow bands of radio frequencies over limited slices of the sky for short windows of time. It is as if you try to judge whether a city is busy by listening for a few minutes at one intersection in the middle of the night. The absence of traffic in that brief interval would not prove very much. The same goes for how we search for megastructures or visible signs of large-scale engineering. We have checked the brightness patterns of many stars, looking for unusual dimming that might hint at giant artificial constructions. So far, nothing conclusive has turned up, but the space of possibilities is enormous. A civilization that wants to harvest its star might do so in ways we have not yet imagined, or that blend in with natural astrophysical phenomena. Our instruments also have limits. The detectors we build in this century may simply be too crude to notice anything but the most blatant cosmic projects. Timing adds another layer. Technological civilizations might be rare in time rather than space. They could flare into existence, broadcast for a few thousand years, and then quiet down, either by choice or through decline. The Milky Way is billions of years old. The overlap between our brief listening window and someone else's broadcasting window might be very small. You can imagine two ships passing in a dark ocean, each turning on its lights for only a few minutes during a long voyage. The odds that those minutes line up perfectly are not high. When you step back, you see that the silence is a small puzzle sitting on top of a mountain of unknowns. It might be telling us that complex life is rare. It might be telling us that self-destruction is common. It might be the result of widespread non-interference. It might mean that we have not looked long enough or in the right way. It might be shaped by the harsh logic of the dark forest, where everyone who speaks too loudly disappears. The data we have so far do not force us into any one of these stories. We are free, perhaps uncomfortably free, to choose which narrative we treat as our working assumption. Each narrative carries psychological weight. Rare Earth makes us feel special and responsible, like custodians of something rare. The great filter in the future makes us anxious and urgent, aware that our current choices might be part of a pattern that usually ends badly. The zoo picture lets us imagine wise guardians and a path to eventual contact if we behave well. The dark forest makes us wary and quiet, primed to see danger in our own broadcasts. These are not just theories, they are mirrors for our values. The one you find most persuasive may tell you as much about your own instincts as it does about the universe. It is also possible that reality will not fit neatly into any single frame. The universe might be a patchwork, some regions full of lifeless planets, some dotted with species that never quite reached technology, some scarred by self-inflicted collapse, some shaped by cautious hidden powers. When we compress that complexity into one simple answer, we risk blinding ourselves to the ways multiple forces could be acting at once. A galaxy with rare intelligent life, frequent internal disasters, and a few dark forest-style actors would still look quiet from where we stand. In the face of all this uncertainty, one fact remains stubborn and simple. We are here, on a small world around an ordinary star, arguing about which story makes the most sense. Our beliefs about the silence will influence what we do next. If we lean toward Rare Earth, we may see spreading life and consciousness into the cosmos as an obligation. If we fear a future filter, we may pour our energy into managing risks and stabilizing our civilization. If we trust the zoo idea, we may look for subtle tests and try to prove we are ready. If we listen to the dark forest, we may pull back from loud messaging and focus on listening and concealment. Before we decide which path to favor, there is another step we cannot skip. We have to ask what these choices say about us. not just about others. The way we respond to the possibility of danger, the weight we give to survival versus ethics, the stories we tell about expansion and restraint, all of these are part of our emerging identity as a technological species. The silence above is a mystery. Our reactions to it are a diagnosis. To see that more clearly, we need to turn the lens inward and ask a harder question. In a universe we barely understand, what kind of civilization are we actually becoming? When we imagine civilizations among the stars making decisions about survival, it is easy to treat them as abstract game pieces. Distant minds, distant risks, distant choices. But the logic we have been exploring did not fall from the sky. We built it out of patterns we know very well from our own history. If we want to understand how a cautious intelligence might behave in a dangerous universe, we do not have to guess what aliens would do. We can start by looking honestly at what we have already done to one another here on Earth. For most of our existence, humans lived in small groups. Villages, clans, early cities. Each one worried about very local threats. A harsh winter, a bad harvest, a rival tribe over the hill. Over time, those groups grew into states and empires. They accumulated territory, resources, and the ability to project power over longer distances. With that growth came a question that sounds familiar now. How do you keep your people safe when others are also growing in strength? When their motives are uncertain, and when there is no higher authority to guarantee that they will not decide to attack? The answers we tried ranged from alliances and treaties to walls and weapons. When neighbours seemed trustworthy and trade was flowing, cooperation felt natural. When fear rose, we built armies and stockpiled tools of destruction. In many eras, the same society did both at once. We negotiated where we could and prepared for war just in case. Behind the speeches and banners, one principle kept resurfacing. It is easier to agree to peace when you believe you will survive either way. It is harder when you sense that a single surprise attack from your rival could wipe out your entire way of life. The 20th century made this tension painfully clear. As nuclear weapons spread, rival nations found themselves in a situation that echoes the interstellar dilemma. Each side knew that the other had the power to cause catastrophic harm. Each side knew that any direct conflict could escalate faster than anyone could control. At the same time, each side had incomplete information about the other's plans and internal debates. The result was an arms race driven by fear of vulnerability. Bombs were built not because leaders wanted to use them, but because they were afraid of being caught with too few if the other side decided to strike. To avoid disaster, we invented measures that would look strange to an outsider who understands only simple logic. We created systems that guaranteed retaliation, even if our own cities were destroyed. We put submarines under the ocean with hidden missiles, built hardened silos, and wired communication networks so that no single attack could knock everything out at once. The goal was to make the first strike option unattractive by promising that any attacker would suffer too. In a way, we tried to solve the chain of suspicion by making it pointless to act on it. You could still worry about what your rival might do, but you could no longer hope to win cheaply by acting first. That strategy, often called mutual assured destruction, feels grotesque when you state it plainly. Safety through the threat of shared ruin. Yet for several tense decades, it helped prevent the world from sliding into an all-out nuclear war. It was not a morally satisfying solution. It did not erase fear. It did not address the underlying distrust between the rival powers. But it did force them to build communication channels, to share at least some information about their forces, and to install safeguards against accidental launches. It was a crude form of stability, balanced on the edge of catastrophe. Now imagine a civilization among the stars trying to invent something similar. There is no easy way to threaten mutual destruction across many light years. If you can hit them, they might not yet be able to hit you back, or vice versa. There is no shared radar network, no agreed-upon monitoring agency watching every launch. The tools that helped us avoid global war on Earth do not scale cleanly to interstellar distances. That is part of why the dark forest logic feels so unforgiving. It plays out in a setting where the stabilizing tricks we invented for our own conflicts are much harder to implement. Even so, our history is not just a catalogue of fear-driven escalation. It also contains experiments in cooperation that went against narrow survival calculations. After centuries of war in Europe, nations built institutions that made another large-scale conflict less likely. After witnessing the horror of global conflict twice, many societies strengthened norms against certain weapons and against total war on civilian populations. International bodies, however flawed, became places where rivals could argue and negotiate instead of shooting. In other words, we did not only follow the harshest version of survival logic, we also tried to tame it. These efforts came at a cost. Nations sometimes gave up short-term military advantages in exchange for treaties. They accepted inspections of their weapons programs, which meant revealing information that could be dangerous in the wrong hands. They submitted to rules that could constrain their behavior in crises. All of this made sense only if enough players agreed that there was value in a stable, less lethal world, even if it meant giving up certain kinds of power. It required faith that others would also honor the rules, or at least that cheating would be rare and punishable. Looking at this, you can see two different instincts wrestling in us. One is the cold, calculating side that says survive at all costs, assume the worst, arm yourself before your rival does. The other is the side that says there is no safety in a world where everyone acts on their darkest fears. It pushes for trust, for building shared frameworks, for accepting some risk in exchange for a better quality of life. In different eras and places, one or the other has dominated. Neither has ever fully erased its counterpart. We carry both potentials at once. So when we talk about the dark forest, we have to ask a hard question. Are we uncovering a universal law of intelligent life? Or are we projecting our own tilted history onto the cosmos? We know that survival pressures can push species towards suspicion and aggression. We know that limited resources and rapid technological change can feed arms races. But we also know that under some conditions, cooperation can emerge and endure, even between former enemies. The model we choose to emphasize will shape not only how we interpret the silence in the sky, but also how we think about our own future behavior. There is a danger in treating the darkest model as destiny. If you tell yourself that every advanced civilization must become a paranoid hunter, you risk justifying your own worst impulses. You might say there is no point building trust, because betrayal will always come. You might say that preemptive strikes are inevitable, that any moral hesitation is simply weakness. In that way, a theory that began as a warning could become a script we follow without question. We could turn ourselves into exactly the kind of civilization we fear, not because the universe forced us, but because we convinced ourselves that we had no choice. On the other hand, there is also a danger in clinging too tightly to hopeful pictures. If you assume that most intelligent species are gentle and wise, you might ignore real risks. You might keep broadcasting louder and louder invitations into the dark, because the story you prefer says that only friends will answer. You might underinvest in understanding potential threats or in building ways to protect your world. Optimism can be as blinding as pessimism if it refuses to look at uncomfortable possibilities. This is where the silence of the sky becomes a kind of test of our maturity. We do not have enough information to prove or disprove any single explanation. We are forced to live with multiple models in our heads at once, a universe where life is rare, a universe full of self-extinguished sparks, a universe watched by quiet guardians, a universe shaped by cautious hunters. We cannot know which, if any, of these portraits is closest to the truth. What we can know is how we behave when certainty is out of reach. Do we default to fear and close ourselves off from possibility? Do we default to hope and act as if danger is impossible? Or can we hold a more complicated stance, one that admits real risks without letting them override every other value? That middle way is harder than it sounds. It demands that we keep updating our beliefs as new data comes in, that we build systems robust enough to handle unpleasant surprises, and that we resist the urge to collapse the unknown into a single, emotionally satisfying story. There is another layer, more intimate and more unsettling. The dark forest picture invites us to think about survival as an absolute priority, yet for individual humans, survival has never been the only thing that matters. People risk and even give their lives for ideas, for loved ones, for strangers in danger, for future generations. Civilizations, too, sometimes choose paths that are not strictly optimal for survival. They invest in art, in exploration, in acts of generosity that may bring no clear strategic benefit. They tie their identity to ideals that could make them more vulnerable in some scenarios, but more meaningful in their own eyes. This raises a question we rarely ask directly. If pushing survival to the top of every decision leads to a strategy that demands preemptive destruction of others, is that really the kind of survival we want? What is the point of living indefinitely if the price is becoming a culture that always shoots first, that never trusts, that sees every new mind as a threat to be managed or erased? At some point, survival without any higher purpose begins to look thin. It keeps the lights on, but it hollows out the story we tell about why being alive matters. We already wrestle with this in small ways. When a society sacrifices civil liberties in the name of security, citizens debate where the line should be. When a government justifies torture or indefinite imprisonment by pointing to threats, many people feel that something vital is being lost, even if the danger is real. We sense that there must be limits to what we are willing to do in the name of staying safe. We do not always agree on where those limits lie, but their existence hints at an intuition. Survival is the foundation, yet it is not the whole house. Project that intuition outward again. If we someday become a civilization spread across many worlds, with access to energies that dwarf anything we wield now, we will carry our ethical dilemmas with us. The question will not just be how to avoid extinction, it will be what kind of presence we want to be in the galaxy. Do we aspire to be a cautious but ultimately open neighbour, willing to take measured risks to connect with others? Or do we train ourselves to think like paranoid guardians of our own dominance, ready to erase others before we know who they are? Right now, these choices might seem far away. We have not yet sent humans beyond our own moon. Our telescopes are only beginning to glimpse the atmospheres of other worlds. Yet the seeds of our future posture are being planted today in how we think and talk about these issues. When we teach ourselves that fear is the only rational response, we cultivate a certain kind of future. When we pretend that danger does not exist, we cultivate another. In both cases, the stories we repeat slowly shape the institutions we build and the technologies we prioritize. There is a quieter possibility, one that sits between denial and despair. We could treat the dark forest logic as a warning rather than a prediction. A warning that under certain pressures, even well-intentioned minds can drift toward harsh strategies. A warning that the combination of survival anxiety, rapid technological growth, and deep uncertainty can push cultures into choices they later regret, if they have the luxury of regret at all. Warnings are not destiny. They are invitations to think ahead and adjust course while we still can. If we accept that we may never have a perfectly clear picture of what other minds are doing out there, we can shift the focus to what we control. We can work to become a species that manages its own power responsibly, that minimizes the chances of wiping itself out through carelessness or internal conflict. We can design our first steps into interstellar space with humility, aware that we might not be the first ones to walk these paths. We can debate openly whether shouting into the dark is wise, and who has the authority to make that choice. Above all, we can decide that our identity as a civilization will not be reduced to a single instinct, no matter how strong that instinct feels. Somewhere above your head, light from ancient stars is arriving, carrying the story of events that happened long before our species existed. That same sky may also contain the quiet work of other minds, hidden in wavelengths we have not yet learned to read, or in patterns we do not yet recognize. We cannot rewrite whatever choices they have already made. We cannot retroactively silence our own early broadcasts. What we can do is decide, here and now, what we want our next moves to say about us. Not just to any hypothetical watcher, but to ourselves. Because in the end, the most important signal we send may not be any particular radio message or probe. It may be the pattern of our behavior over time, the way we balance caution and curiosity, power and restraint, fear and hope. That pattern will tell any future observer, human or otherwise, what kind of mind finally emerged on this small blue world, and it will shape the answer to a question we have been circling all along. In a universe that might be dangerous and that is certainly indifferent, Can a civilization choose to act not only from fear of death, but also from a deeper sense of who it wants to become? If the universe is a dark forest, or a rare garden, or a quiet zoo, or something stranger than any of those pictures, we cannot change that fact by wishing. What we can change is how we move through it. Every choice we make about speaking or staying silent, about building beacons or dimming our lights, is really a choice about who we want to be when we take our first real steps beyond this world. In that sense, the question of how loudly we call out to the stars is not just a technical problem, it is a moral and cultural decision about the story we are writing together. One way to respond to the uncertainty is to pull back. We could decide, as a species, that until we know more about what is out there, our default stance should be quiet. No new high-power beacons, no deliberate attempts to send rich messages to specific stars. We continue to use radio and lasers for local communication, but we shape our infrastructure to leak less, to be more directional, more efficient, less like an exploding lantern and more like a set of carefully shaded lamps. In this mode, we are not hiding in panic, we are simply refusing to shout into a dark room before we understand who might be in it. There is a kind of discipline in that posture. It would mean saying no to projects that promise excitement and headlines in favour of a more patient, long-term safety. It would require cooperation among nations and organisations, because a single powerful transmitter can undo the silence of everyone else. It would also demand an honest public conversation about risk. Before any group decides to point a bright signal at the sky, they would have to explain why they believe the benefits outweigh the unknowns, and why they are entitled to gamble with a decision that affects every human being, present and future. Done well, a quiet strategy does not have to feel like fear. It can feel like listening. Instead of pouring our resources into messages that rush outward, we deepen our search for whatever faint signs might already be coming in. We build better telescopes, more sensitive receivers, more sophisticated algorithms for spotting unnatural patterns in noise. We turn ourselves into careful observers, trying to understand the galaxy before we try to join any conversation. There is humility in that, an acknowledgement that we are young, that we have much to learn, and that patience is not the same as paralysis. At the same time, pure silence carries its own costs. It can slide into isolation, into a bunker mentality where the only value that matters is not being noticed. If we define ourselves entirely by caution, we risk forgetting why we cared about the cosmos in the first place. Curiosity, wonder, and the desire for connection are not trivial luxuries. They are part of what makes a technological civilization more than a survival machine. A world that only ever hides may be safe for a while, but it may also grow small inside, turning away from the very possibilities that once drove it to build radios and rockets. That tension points toward a second path, one that tries to walk between shouting and silence. In this path, we accept that total concealment is probably impossible, but we also reject the idea of indiscriminate broadcasting. Instead, we treat any deliberate message as something that must be crafted with as much care as a constitution or a global treaty. We ask hard questions about content, intent, and representation. Who speaks for Earth? What do we choose to share about ourselves? What tone do we take toward unknown minds who may read our words centuries or millennia from now? A carefully curated message is not just a catalogue of facts, it is a self-portrait. We could choose to present ourselves as flawless, hiding conflict and cruelty behind a mask of harmony. That might make us feel safer, but it would also be dishonest. We could decide to highlight our worst traits, confessing every disaster and atrocity in a kind of cosmic cautionary tale. That might be disarming, or it might make us look unstable and dangerous. Somewhere between these extremes lies a more honest option. We can say that we are a species capable of both beauty and horror, that we know this, and that we are trying, imperfectly, to tilt ourselves toward wisdom. Designing such a message would force us to confront our own contradictions. Do we really value cooperation more than domination? Are we willing to invest in long-term stability instead of short-term gain? When we claim that we are learning from our mistakes, can we point to concrete examples where we have changed course in the face of danger? In this way, the process of deciding what to say to the stars becomes a mirror. If we do not like what we see, The answer is not to lie outward. It is to do the harder work of changing inward, so that any honest self-description is less embarrassing. There is also a third path, the boldest and riskiest. We can decide that the potential value of contact is so great and the loneliness of isolation so heavy that we are willing to announce ourselves loudly and clearly, despite the unknowns. In this mode, we build beacons not as stunts, but as long-term projects. We send out detailed messages about our science, our art, our history, our dreams. We accept that any civilization with the power to destroy us probably already has other ways to find us if it wants to. We choose, in other words, to live as if the dark forest picture is wrong, or at least incomplete, and as if the universe rewards openness more than secrecy. This is not a purely naive stance. Some people who favour active messaging are fully aware of the dark forest argument. They simply judge that a life spent in permanent fear of unlikely but catastrophic scenarios is not a life they want for our species. They point out that on Earth, many of our greatest advances came from taking risks, sailing into unknown oceans, splitting the atom, mapping the genome, exploring the deep sea. In each case, there were voices urging caution, sometimes for good reason. Yet without a willingness to step into the unknown, cautiously but deliberately, we would still be huddled in small bands, telling stories about the stars instead of studying them. Of course, there is a difference between daring and recklessness. Sailing across a risky sea is not the same as lighting a beacon that could, in theory, draw the attention of something far more powerful than us. The question is how we decide where that line lies. At what point does caution stop being wisdom and start being a cage? At what point does boldness stop being courage and start being a disregard for consequences? These are not questions anyone can answer with equations alone. They are questions about what we value more: a slightly higher chance of survival, or a richer, more engaged existence that carries greater risk. The truth is that we are already making similar choices in other domains. When we deploy new technologies on our own planet, from artificial intelligence systems to genetic engineering, we are deciding how much risk to accept in exchange for potential benefits. When we burn fossil fuels or clear forests, we are gambling with the stability of the climate that supports us. When we build weapons that can kill millions in an instant, we are trusting our future selves to handle that power with restraint. We do not always make these choices wisely, but the patterns we establish here will echo in whatever decisions we make about the larger cosmos. If we cannot manage our own impulses on one small world, why should we trust ourselves with the responsibility of broadcasting our presence to others? If we cannot cooperate across borders to handle known threats, how will we cooperate to handle unknown ones? Before we worry too much about hypothetical alien hunters, we might need to prove that we can avoid becoming our own worst enemy. In that sense, the dark forest is not just an imagined landscape out there. It is also a metaphor for how we navigate the tangle of our own fears, ambitions, and conflicts. There is a hopeful angle hidden inside that metaphor. By confronting the possibility that survival at any cost can lead to terrible actions, we are pushed to articulate something better. We can decide that we want to be the kind of civilization that balances prudence with openness, that refuses to commit moral atrocities in the name of abstract safety, that does not let fear completely dictate its behavior. That does not mean ignoring danger. It means refusing to let danger be the only voice in the room. Imagine a future where we do reach the stars, slowly at first, then with growing confidence. Our probes explore nearby systems. Our descendants build habitats on moons and in deep space. We learn to manage our own technologies without constant crisis. In that future, our message to the galaxy might not be a single broadcast, but a pattern of behavior visible from far away. From the outside, someone might notice that our planet's atmosphere stabilized after a period of dangerous warming, that our energy use stopped rising without bound, that our space traffic appears orderly rather than chaotic and violent. Those would be signs not just of power, but of restraint. From that perspective, the most convincing statement we could make about our character would not be written in radio waves at all. It would be written in the way we treat our own world and each other over long stretches of time. A civilization that learns to live within the limits of its planet, that avoids escalating every conflict into catastrophe, that invests in knowledge and art as well as defense. That kind of civilization tells a story about itself without needing to shout. Any distant observer who can read the signatures in light and chemistry would see not just that we exist, but that we found a way to endure without turning everything into a battlefield. None of this requires that we settle, today, on a single permanent policy about cosmic communication. Policies can evolve as our knowledge grows. We might begin in a relatively quiet mode, focusing on listening and internal stability. As we gather more data, we might adjust, deciding that certain kinds of modest messages are acceptable. We might develop international agreements that govern active signaling, the way treaties now govern nuclear testing or environmental protections. The important thing is not that we get everything right immediately. It is that we treat the question with the seriousness it deserves, as a shared decision about our long-term trajectory, not as a marketing opportunity or a technical stunt. As you think about all this, it may be tempting to ask for a simple answer, a clear prescription. Should we build beacons or not? Should we hide or wave? Part of growing up as a species may be accepting that some questions do not have clean answers yet. The universe has given us a puzzle with almost no clues. Until more evidence arrives, we have to live in a space where multiple stories remain plausible. In that space, the wisest thing we can do is build a civilization that would be worth meeting, whether we ever meet anyone or not. On some future night, perhaps centuries from now, a human child may stand under an alien sky on a world that once was only a point of light in our telescopes. They may look up at unfamiliar constellations and know that somewhere back on Earth, their ancestors once debated whether it was safe to take the journey that led here. By then, we will have answered at least some of the questions that haunt us now. We will know more about the odds of life, about the presence or absence of other minds, about the true character of the galaxy we live in. What will still matter is whether we found a way to expand without becoming monsters, whether we learn to carry both caution and curiosity without letting either one erase the other. For now, we stand at the very beginning of that story. The sky above looks empty, but it is full of possibilities, some bright, some bleak, most still beyond our imagination. We cannot choose what the universe is. We can only choose how we respond to what we find. Do we listen more than we speak? Do we speak with honesty when we do? Do we build tools that amplify our worst impulses, or ones that help us act from our better ones? Those choices are within our reach, here, on this small world, under this familiar moon. Whatever else may be out there, distant and silent, they will see us, if they ever see us at all, through the sum of those choices. Long after our first radio signals have faded into the background, the imprint of how we lived, how we treated each other, and how we stepped into the wider cosmos will remain written in the light of our star and the thin, fragile film of air around our planet. In that sense, the question of whether to whisper or shout into the dark is really a question about the story that light will tell. And that story is still, for the moment, entirely in our hands.